In this session, we will be discussing about arrays and strings. In arrays, we will discuss different types of searching techniques and sorting techniques, and also 2D arrays. So without any delay, let's start the session. First of all, what is an array? An array is a variable that can store multiple values. Or you can say that it is a collection of similar type of data items. In simple terms, you can say that it is a collection of similar type of data items. Nothing but the slots whichever are there in the arrays must be of same data type. And they are the derived data type in C programming language, which can store primitive type of data such as int, character, double float, etc. And remember, they are stored at the contiguous memory allocations. Nothing but simultaneously, one after the other, the memory is being allocated for each of the slot in the array. You can check the example here. There are different slots in the array. The size of the array is 10 and starting from 0, remember the array starts from 0th index, starting from 0 till 9. These are the indices and the slots, the space over these each index. You can check here. And there is an element at the 5th index. And the length of the array is 10. So this is the general structure of your array. You can check how to declare an array. Simple, int a square brackets of size of the array. Inside the square brackets, you need to write the size of the array. Suppose if you write 3, then there must be 3 elements. The first element will be 0th index, second will be first index, and the third will be second index. Okay, and you can also specify or you can also initialize the elements in the array. Like for example, int a of 3 is equal to 1, 2, 3. Nothing but you have given the values for the space. For the 0th space, the value is 1. For the second, it is 2. For the third, it is 3. And you can see the second example as well. Also, you can give an empty space for an array like this. And also, you can give array inside an array. Okay. This is the example of your array declarations. And these are the example of array pointers, int star a or int star a. In this way, you can declare your array pointers. Now, let us get into the programs of arrays. This is a simple program where you can find minimum, maximum and average of set of elements in an array. Suppose set of elements are given for us. Let us take those elements, right? 50, 60, 10, 20, 45. Okay, these are the set of elements given to us. And it is the main function where we are defining the iterative variable I and the number of elements where your array stores minimum element as min, maximum element as max, and to find average you need sum of the elements, and I'm using sum. The very important is array declaration. Array of 10, nothing but it is an array of size 10. These are the declarations. And to find out average, that is the value in float, I'm declaring it as float average. Okay, and this is the input statement where how many elements you want to store, and this is the printf statement to store the values. Okay, how many values you want to store and what values you want to store. So remember, while storing the values inside your array, you definitely need a for loop. So I'm using a for loop till the end of the array, nothing but till the n is nothing but the size of the array. Total number of elements you want to store is nothing but the size of the array. So till the size of the array, you need to give each and every element. Okay, so using scanf, what we are doing, whatever the elements which we have written. So here writing the elements, or you can say values, and here scanning the values and putting them inside the array indices, or you can say index. Okay, so for each index, like for first iteration it is a of I, the first value will be, a of 2 the second value, a of 3 the third value, in that way, based on the total number of elements you specify to store. And the basic initializations, as we have discussed many times, initialization is very important. And here for all min, max, and for sum, everything we are initializing it as what? Array of 0. Nothing but the first term in the array is being initialized. Now here comes the main logic. So what is the main logic is, you need to find the minimum value, right? Run a for loop till the size of array. So inside what happens is checking if the first element is less than the min. So min is nothing but 0th element in the array, and the a of I is nothing but, that's why remember this is very important, you have initialized the first location, that is the 0th index location, as sum, min, and max, right? So your for loop must start with second number, nothing but start from second index. Okay, nothing but that is 1, right? Second index is nothing but 1, or second element is nothing but 1. You can say element, that is first index. Okay, so if the first element, nothing but, you can say that as a first indexed element is less than the min is nothing but 0th indexed element. So if this condition is true, then minimum is being reassigned as a of I is nothing but, now here it will be 1. Okay, or you can say the I with which the loop has started. Okay, a of I with which the loop has started. And if a of I nothing but the second or the index 1 element is greater than the max is which was initialized as index 0 element, if it is greater, then obviously this will be your max, right? So simply reassigning, same story again, reassigning the max element. Okay, nothing but a of I is the maximum, we are reassigning. So in this way we are writing to if conditions to print the sum of the array elements. Simultaneously we are writing sum equal to sum plus a of I. A of I is nothing but for each element, initially sum was a of 0, so a of 0 will also get included, plus what we have given, a of I, nothing but from first index all sums will be calculated here, and it will be assigned to the sum variable. So in this way you can find out minimum and maximum and also sum. So I hope this condition is very simple, right? It is you can take this example, right? Here the first element is 50. So what I am doing here is minimum is 50 and checking for is 50, checking minimum is 50, right? So checking is 50 greater than 60, is 50 greater than 60, is it true? No. So obviously 50 only will be your minimum value. Now again what you need to do, check 50 for 10. Okay, sorry, check 50 for 10 and again check 50 with 20. Okay, in that way, not checking only 50, but if you got least element, suppose you got here 10 as least element, now it will change to 10. Again checking 10 with 20, no change. Check 10 with 45, no change. So your minimum element is what? Minimum is this one. This way you can find out. So the same story comes with maximum. What you need to do? 50 and 60, comparing this both. That is only this condition, right? A of I greater than max. A of I is nothing but first index, this one. Like this. A of I is nothing but 60, right? Right. 60 is greater than 50. Is it true? Yes, it's true. So 60 will be as it is. 60 greater than 10, true. 60 greater than 20, true. 60 greater than 45, true. Finally, max will be assigned as 60. And sum, how it will be there? Sum equal to sum plus A of I, right? Initially it is 60. Initially it was 60. But what we have initialized as sum to be 50, nothing but A of 0 is been initialized as sum, right? A of 0 is nothing but 50. So 50 plus 60. So your output is 110. Now again this 110 will get added up with next A of I, nothing but 10. Again 120 you will get. This 120 will get added up with the next one, 20. Similarly with 45, next one. So this is what? 140. Finally you will get the output as 185. In this way the sum is being calculated. Very simple program. Okay, this is the main logic you need to understand. And after this logic, obviously you can print the minimum, that is the percentile d, the maximum, and average is nothing but we have found the sum, and here n is taking your length of the array, right? So sum divided by n, and float is what here? Type conversion you are doing. Okay, what is type conversion? Just sum is integer, right? But you want to store float, so float of sum divided by n. Okay, so here comes the average value and it is been printed here. Let us check. Suppose 1 2 3 4 5, I want to store 5 elements: 50, 60, 10, 20 and 45. You can check. Okay, smallest is 10, maximum is 60, and average I have found here sum, but average is 185 divided by 5, so it will be 37. That is the story. 185, average is what? 185 divided by 5, so it is 3 times 5, 3 times 15, and 35 is 7 times. This is your average value. Okay, very simple program. Finally we are returning 0. What we are doing, we are initializing the minimum, maximum and sum to the 0th index value. After that we are comparing that 0th index value with the second, nothing but the first index value, to calculate minimum and maximum. That is the basic thing which you know, right? To find the minimum or maximum, and to find the summation, you are adding the next terms. Okay, the second term, the third term, the fourth term, etc. This is about array minimum and maximum and average. Now let us learn about 2D arrays. 2D array is nothing but 2-dimensional. One-dimensional is nothing but where you can store only linear kind of values. 2-dimensional is nothing but where you have rows and columns, right? You can check here. There are 3 rows. It is a 3 by 4 matrix. You can check. This is the declaration. I have just taken a data type float. Float x. X is my name of the 2D array, and 3. The first one represent the rows, 3 rows, and 4 represent the columns, 4 columns. So you can check how each column has its value. X of 0 0, 0 1, 0 2, 0 3. This indicates 0 1 2 3, 0. This indicates 0 1 2 3. Okay, 0 1, 0 2. Sorry, 0 0. 0 1, 0 3 indicates this, 0 4 indicates this. Similarly, 1 0 indicates this, 1 1 indicates this, 1 3 indicates 1 2 indicates 3, this 1 3 indicates this. Similarly, 2 0 indicates this, 2 1 indicates this, 2 2 indicates this, and 2 3 indicates this. Okay, this is your small representation of 2D array. So the best example for 2D array is matrix, obviously, right? So let us look deeply in the matrix programs immediately. This is a sample program for displaying a matrix. Okay, I have taken the size to be 10 by 10. Okay, don't think that if we take a size 10 by 10 then I need to specify 10 by 10 elements. It's not mandatory. You can specify less elements as well. Okay, and mn are nothing but rows and columns. Ij are nothing but for rows and columns. In the nested loops we have used I and j, right? Iterative variables. Okay, these both are what? Iterative variables. The first is input, where you need to enter the size of the matrix. Whatever the size you want to give, you can give. Suppose 3 by 3 matrix you want, or 2 by 2 matrix, in that way. Okay, and enter those elements. Obviously I said to enter the elements you need to use a for loop. As you know that for loop is very important to enter the elements, because it needs to insert each and every element inside your 2D array. So taking for loop from 0 till m and incrementing j0 till n, incrementing, you need to scanf that %id into matrices mat, that is the name of your array of I and j. 0 0 0 1 0 2, in that way. Again 1 0 1 1 1 2, again 2 0 2 1 2 2, in that way. Okay, the elements are being stored, and also I am printing the matrix elements. Okay, so remember we are printing the matrix elements in the form of matrix representation. Okay, matrix representation. You can check first printing the first element. Okay, for this for loop it prints the number of columns. Okay, first it prints columns, right? Inner loop columns, new line. So after printing that column, first column, after printing the first column, go new line using backslash n. Okay, and after that second row you need to print the second column, second column. In that way the columns are being printed. That's it. Taking the elements and printing the elements in the matrix format. That is only simple example of reading and displaying the matrix. So let us execute it. Suppose I want a 2 by 2 matrix elements. 2 by 2 in the sense 4 elements, 0 1 2 3. That's it. This is your matrix representation. 2 by 2. I've written m is 2 n is 2. So for I0 I less than 2. So 0 0, this is 0 0, this is 0 1, this is 1 0, this is 1 1. So for each part, whatever you have mentioned here are being allocated. Okay, the values whatever you mentioned here above, print the printf, those values are allocated inside the using the scanf. Okay, and if you want to print, you can print it in this way. This is a sample example how to print a matrix. Okay, now let us move on to matrix addition program. So you want to add two matrices. Okay, two matrices. How you will add? Simple. You need two matrices A and B, and also if you want to add, you need an external variable to store that addition. So I'm using, to store that summation or addition, you need an external variable. I'm using here C, and I, j iterative variables, row 1, column 1 for A matrix, row 2, column 2 for B matrix. These are the basic things which you will be writing. So everything must be read by the user, or you need to specify everything, nothing but order of matrix A, nothing but R1 and C1. What is the uh, what kind of matrix, 3 by 3 or 2 by 2? Okay. And for matrix B, R2 C2, what kind of matrix, 3 by 4 or 4 by 3, 3 by 3 matrix. Okay. And in order to check the addition, okay, in order to check the addition, the basic thing is what? Both sizes must be same. Okay. Sizes in the sense, suppose if I take 2 by 2 matrix and if I take one more 2 by 2 matrix, so can you do addition? Yes, you can do addition. Can you do addition here? Yes, you can do. Suppose if I take 2 by 3 and 2 by 2, can you do addition? No, it can't. Okay, so that's why I'm saying the first row in the first matrix and the second row and the say row in the second matrix must be same, and the column in the first matrix and the column in the second matrix must be same. Then only you can do the addition. So your addition is no. So here I have done the same thing. R1 represents the row of the first matrix, R2 is the row of the second matrix. So both must be same, as well as nothing but not only this must be true, but also the columns of both the matrix also must be true. Then only you can add. Okay. And in after it else case, you have written addition not possible. Okay. This is the main if condition where you write your big program. So simple steps. You need to read matrix A, you need to read matrix B, and you need to perform C, that is addition, and finally you need to print A, B and C. Nothing but A, B and addition. Very, very simple. It looks complicated, but writing is not a big deal. So first step is taking the inputs. Okay, inputs of matrix A. Inputs of matrix A. Matrix A contains R1 and C1, rows and columns. Okay, scanning them like for 0 0 0 1 1 0 1 1. Okay, similarly doing the same thing R2 here and C2 for them scanning. Same story here 0 1 0 0. If I take 2 by 2 matrix, okay, for 3 by 3 it varies. And finally, after taking the inputs, here we are taking the inputs using scanf. We are adding both of them, and remember addition is also you need to do a for loop because each element in A adds up with each element in B. Okay, there comes the usage of it where you are writing C of I comma j. C is also a matrix. So we are writing A of I comma j plus B of I comma j. Nothing but for, let us take 0 0. A 0 0 plus B 0 0. Again A 0 A 0 A01 B01 in that way. Okay, you need to add the elements in the matrix, and this comes the end of your logic. After this you need to print the matrix A. Simple, we have scanned the matrix A here, and the same part we are printing it using a for loop. Okay, and also we are giving a tab space to have a gap, have a element gap, and after each column we are keeping new line. Okay, these two points are important. And after that, similarly to print B also, the same part we are doing from R1 C1. Here we are taken R2 and C2, printing the columns first and giving a space, printing the next column in that way. Okay, and finally the same part to print C. But here you will be getting a doubt that C has what rows and what columns. Remember, you are adding both the matrices, nothing but both the matrices have the same R by C value. So here you have taken R1 and C1, right? You can take R2 and C2 also. There is no problem. Okay, you will get the same output because that is a fixed length for your matrices. Both for R and for C, R by C for A and for B. For both of them, the row column values are same, right? By this condition, whatever in the if condition we have written, right? So that is the most important part. That's why we have taken R1 and C1. Take the first row of the A matrix and the first column of the B matrix inside this inner loop and printing each of them C01, C10, C00 in that way. Okay, and after each column we are explicitly specifying the new line here. Okay, and this is the else case which we have discussed, where we are writing addition is not possible. So let us discuss briefly once again what happens here is, we have taken three matrices A, B, C, and we have taken two iterative variables ij, and matrix A contains one row and one column and matrix B contains one row and one column. First step is, we have taken the order of matrix A, nothing but enter row of this, enter column of this. Okay, and we have scanned them, that is here. And for B also we have written enter row and column for this, and we have scanned. And we are checking that if R1 and R2 and C1 and C2 are same, if both the condition holds true, then you read matrix A, nothing but you just enter the values of your matrix. Okay, enter the values, and using a for loop you just scanf those values into your A array, into your what? A array, or you can say A matrix array. Similarly for B, taking from R2 and C2, scan them into B matrix array. And here C, here comes the main logic. C of ij is equal to A of ij plus B of ij, whereas C is also a matrix. Okay, and here also you can take R1 and C1 or R2 or C2, depends. And finally we are displaying the matrix. Here instead of scanf you are simply using printf. That is the only difference between reading ABC and printing ABC. But you need to remember, in order to print that in matrix format, then you can use this new line, and you can use this new line. For all you can use that new line. And if in else case, if R1 R2 are not equal, or C1 C2 are not equal, if any one of them is not equal, then addition is not possible. You can run order of matrix A 3 by 3. Here I am giving 3 by 3 as well. 0 1 2 3 4 5. I have given 1 2 3 4 5 values, 6 7 8 9. 1 2 3 4 5 6 7 8 9. Yeah, you can check. This is the matrix A, this is the matrix B, and adding 0 plus 1, 1 plus 2. So each item in this and item in this are being added up. That way your matrix C is being displayed. This is your addition of matrix. Next, multiplication of matrices, which is almost similar. Okay, everything is similar. Which varies is the condition which you specify. Suppose if C1 and R2 are not equal, then it is impossible to find the multiplication. C1 and R2, nothing but if there are two matrices, let us assume that A matrix has R1 by C1 order and B matrix has R2 by C2 order. Okay, when you can do multiplication is nothing but the first row multiplied with the first column, first row multiply with second, first row multiply with third. In that way you will be doing, right? So you know that if we take 3 by 3 matrix and 3 by 4 matrix, you take these both matrices, then what is it possible? Multiplication is possible, yes. Why? Because C1 this and C1 and R2, R1 C1, R2 C2. Okay, R2 and C1 both are same, so you will get the output as what? 3 by 4, nothing but this matrix you will get. You need to neglect this and you will get a 3 by 4 matrix as your output. So this is very important while doing matrix multiplication. This condition is very important. And the same story comes reading the matrix A, reading the matrix B. A is being stored into the array A and B into the array B, and the main logic where it varies, your matrix will be what? Of 3 by 4 here. 3 by 4 is nothing but R1 C2. So your for loop in the multiplication nothing but for C, the for loop runs is R1 by C2. So why? The reason is here. If these both are same, multiplication is possible and output will be in this form, starting element and last element, nothing but R1 C2 form. So same thing applied here, R1 and C2, iterating variables. Okay, outer variable R1, inner variable C2, and we have specified similarly C of I comma j, that is C of ij as 0, and we have taken explicitly a variable k. We are running another for loop. Variable is what? K, and what we are saying is add C of ij to what? A of z ik and bkj, nothing but, you can take an example, right? A of 0 and 0 multiply with b of 0 and 0, b of 0 and 0, and after incrementation of k, 1 and 1, after incrementation of k, 2 and 2. So in this way, so you know, right, matrix multiplication, the first row first element multiplied with the second row first element. Similarly, the first row second element multiplied with the first row second element. In that way, the multiplication is being done. Ik multiplied with kj. Okay, and after this comes the end of your logic, and the final thing is you need to display the matrices A, B and C. Using a for loop, giving the new lines for each column, you are displaying A, displaying B and displaying C also. Again we are using R1 by C2, okay, because you need to get the output in that order. That is the most important thing. While reading C and while doing the addition, nothing but while calculating C and also while printing C, the row by column order is the most important thing. It must be the first row of the first matrix and the second column of your second matrix. Okay, and else case, if R1 C1 and R2 nothing but the first row, the first matrix column and the second matrix row are not same, obviously multiplication is not possible. That is your output.